All right, welcome. Today, we're going to do something a little different. We're putting on our engineering detective hats to dig deep into a really critical EV incident. We're not just going to look at what happened, but we're going to peel back the layers to understand why it happened using this really powerful technique. So let's get right into it.
So, picture this. It's a pretty alarming scene. An electric vehicle, a symbol of our high-tech future, completely engulfed in flames. Now, this isn't just some random accident. It's a major failure that sparked this incredibly intense investigation. And the immediate culprit? A nasty little phenomenon in the battery pack called thermal runaway. So, what in the world is thermal runaway? Well, the easiest way to think about it is like a vicious, unstoppable cycle. One battery cell gets too hot, which then heats up the cell next to it, which heats up its neighbor, and so on. It creates this chain reaction that just escalates like crazy. Now, that's the technical reason for the fire for sure, but as you'll see, it's nowhere near the whole story.
To really get what happened here, we have to rewind the tape. We need to trace this failure right from the very beginning.
It's a classic domino effect, really. It all started with just a few battery cells getting a little too hot. Now, the cooling system, which is supposed to kick in and stop this, completely malfunctioned. That allowed the temperature to just spiral out of control, which is what officially kicks off the thermal runaway. And from there, you get the fire. Okay, so with that sequence of events laid out, the engineering team started their deep dive, their forensic analysis, and their tool of choice, a method called the 5 whys. It's actually a deceptively simple idea, but it's incredibly effective. You just keep asking why about 5 times to peel back all the surface-level problems until you get to the actual, true root cause. So the investigation kicks off. First question, the most obvious one you'd ask. Why on earth did thermal runaway happen in the first place?
The first answer is pretty straightforward, right? We just saw it. The cells overheated, and that's what started the chain reaction. But this is just scratching the surface. Any good investigator knows this isn't the real answer. It's just the first clue on the trail.
So we have to dig deeper. If overheating was the trigger, the next logical question is, why did they overheat? What was supposed to stop that from happening? And boom, there it is, our first major break in the case. The cells overheated because the one system that's specifically designed to prevent that, the battery's cooling system, it failed. So now, the investigation has a much sharper focus. We're not looking at the whole battery anymore. We're looking at one specific critical system.
This is where the detective work starts to get really fun. Now that we've ID'd the failed system, we've got to find the exact component that was the culprit. And that brings us to why number 3, taking us down to the component level. What part of that cooling system actually broke? Well, the investigation quickly narrowed it down to 2 main suspects. The evidence pointed to one of 2 things. Either the temperature sensor went bad, which basically means the system was flying blind and had no idea the heat was rising, or the coolant pump itself failed, meaning the system couldn't move the coolant around to cool things down. Either way, a really critical failure.
So we ask, why? Again, for the 4th time, why would a sensor or a pump just fail like that? Well, it could have been a bunch of things. Maybe it was calibrated wrong at the factory. Maybe it got damaged from years of road vibrations. Or it could have been something as simple as contaminated fluid or a bit of debris causing a blockage. But here's the twist. Even these physical problems, they aren't the real answer.
And that brings us to our 5th and final why. And this is the most important question of all. What allowed these physical failures to happen in the first place? Why wasn't there a backup, a fail-safe? What was the real root cause? And this is the moment that changes the entire investigation. Because the final answer wasn't a broken part or a faulty wire. The real root cause wasn't technical at all. It was organizational. And suddenly, the whole picture just snaps into focus, right? A physical part failed because of shoddy quality control during manufacturing. A single point of failure turned into a catastrophe because the design didn't have any redundancy built in. And the problem wasn't caught early because the maintenance procedures just weren't good enough. That faulty part, it was just a symptom of a much, much deeper problem within the organization itself.
You know, finding the root cause is one thing, but fixing it, that's the whole ballgame. With this new crystal clear understanding of the systemic failures, the team put together a really comprehensive action plan to make sure this could never, ever happen again.
And their response was methodical and smart. Immediately, they inspected the entire fleet and pushed out a software update with better warning alerts. Then, in the medium term, they totally overhauled their quality control and started building in that redundancy that was missing. And for the long term, they committed to a complete redesign of the cooling system from the ground up. See? They're fixing both the symptom and the disease. And this wasn't just some "we promise to do better" plan. Nope, they made it completely data-driven so they could hold themselves accountable. They started tracking specific metrics, key performance indicators, or KPIs, aiming to lower the average cell temperature and get that critical component failure rate down to almost zero. This way, success isn't just a feeling, it's something you can actually measure. So let's zoom out for a second and talk about the lessons for the future. Because the impact of this one single investigation goes way beyond this one car or this one company. It actually sent ripples across the entire auto industry. So why does this matter to all of us? Because this single incident has literally pushed the entire industry to be better. It's forcing a review of safety standards, it's driving new investment in R&D, and it's even getting competitors to work together on safety issues. It's also leading to much better training for the mechanics and first responders who have to deal with these vehicles every single day. You know, in the end, the conclusion from the investigation itself really says it best. As painful and as public as this whole thing was, the knowledge they gain from it will directly lead to safer electric vehicles for everybody. It's a powerful reminder that sometimes real progress comes from taking a hard, honest look at our failures. And that leaves us with one final thought to chew on. When something like this goes wrong, is it just a failure that we should condemn? Or is it a critical, maybe even invaluable opportunity to learn, to improve, and to build a much safer future? Thanks for joining me for this analysis.